So this project is going to be about center of mass, which is also like a balance point. So we'll talk a little bit about why that's important and why it's calculusy. So here's a formula. Now I'm going to show you this page out of, this is actually my original calculus book that I learned from back in the day. And I'm going to post this page so you can look at it, and it's talking about if we have some masses distributed at a certain distance from an origin, then we can calculate where that center of mass is using this formula right here. And you can see how that's going to lead to something calculusy. And they show how you derive that. It's pretty interesting. I'm not going to focus on that. We don't even really need this. It's just sort of a launching point for this discussion, because this is really talking about point masses. And we're going to do distributed masses. So this formula is basically saying if I want to know where the center of balance is, I add up the position times the mass for each of my discrete masses, and I sum those, and then I divide it by the sum of the masses. So let's look at what that looks like for a specific example. So what I have here is a ruler, and my ruler has to be of negligible mass compared to my point masses, which is my quarters that I'm using. All right, so now what I have already sort of set up and tested out is using, I'm going to place 5 coins at 5 centimeters. So I have to try and really make sure that we're really dealing with the center of mass of this stack of coins, which I think should be obviously at the center. So I want the center of the coins to be as close to 5 centimeters as I can make it. And then I'm going to put 8 coins. I'm going to just slide this over so I can slide this little, this is just my handle to lift it with. It's actually a pointing trowel for masonry. I'm going to put 8 masses at a distance of 23 centimeters. So there's 23 centimeters. I'm going to try and put the center of the coins right there. Okay, now what we're going to do is calculate where is the center of balance of this system with the ruler and the coins. All right, and really the ruler is of negligible mass, so we're really looking at just where is the center of mass of the coins. And we'll see a system that actually makes sense too. So what I do is I just do this formula. So for my first group, where I have 5 coins at 5 centimeters and 8 coins at 23 centimeters. So that means that this formula for my x bar is going to be the sum of 5 times 5 plus 8 times 23 over the sum of my masses, which is just 5 plus 8. And essentially what I'm doing is using the unit of mass here is quarters. All right, so I have 5 quarters plus 8 quarters, that's my unit of mass. So the unit of mass ends up being irrelevant because it appears in the top at the bottom and it cancels out. All right, so you can see I've set up some calculations already. Let's just go ahead and set this one up for new. So it's 5 times 5, which I know is 25, plus 8 times 23, which I don't happen to know off the top of my head, so I'll put that in there. And then 5 plus 8, I'm pretty sure is 13. All right, and I get 16.07. All right, so that center of mass is 16.07. Now, there are necessarily some inaccuracies in the setup because my quarters might not be placed exactly. I'm neglecting the weight of the ruler, but the weight of the ruler actually plays a role, as I found out with if you don't use enough mass, it makes a difference. All right, and I only put this stack of quarters here to weight the trowel down so it doesn't fall over. Now I can take it off. So we're saying that balance point is at 16.07 centimeters. So basically, I made this sort of flat so that it can account for some of those inaccuracies. So I'm going to move the center of the trowel to 16. And what should happen is I should be able to lift this, and it should balance perfectly. So I lift it up, and I can see that the whole thing comes up together. It's balanced, right? If I look at it from the edge, risking you seeing how messy my desk is, looking at it from the edge. So if I pick it up, we can see that it balances nicely. All right. Now, just to show you that that's not, well, you could have put it anywhere and it would have balanced. Not really. Look, if I put it at 17 centimeters, even off by 1 centimeter, okay? Now, if I try to pick it up, see how only one side of it comes up? It's because it's not balanced. So being off by 1 centimeter causes it to be so that if I try to lift it up, it's not balanced. All right. So I missed the balance point by 1 centimeter. That's why I had to calculate the balance point to start with. So I think in the interest of being careful with time on these videos. I'm going to cut to a second video to show you a second example of this.